so much fun for everyone. Math.
The four Mathsketeers.
Hi guys, welcome to another video of Mathsketeers, and today we will be discussing about solving quadratic equations. I'm Jessica Theodora and I hope you'll enjoy this video. Quadratic equation. The general formula for a quadratic equation is shown as ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant. Now note here that a should not be equal to 0. Why is that so? Well, because if a is 0, the equation of this formula will be 0x squared plus bx plus c, which is also equal to bx plus c. Now we know that bx plus c is not a quadratic equation because the exponential of x is 1. So therefore a should not be equal to 0. Now in quadratic equations we have what we call solutions. The solution of the equation is where the equation equals to 0. So we can express that as ax squared plus bx plus c equals to 0. The solutions of a quadratic equation is also called as roots or zeros. When we graph a quadratic equation, it would look something like this. And the solutions of the equation here is the intersection of the graph with the x-axis. So we have two solutions here, which is approximately x equal to negative 2.4 and x is equal to 0.4 here. There are several ways in solving a quadratic equation. The first one is by factorizing. The second one is by completing the square. And the third one is by using quadratic formula. Last one is by drawing a graph. So first of all, factorization. How do we factorize a quadratic equation? Let's say we have this equation, x squared plus 4x plus 3. First of all, we need to identify the a, b, and c values of this equation. So we know that the general formula of a quadratic equation is ax squared plus bx plus c. So here a is equal to 1, b is equal to 4, and c is equal to 3. Now let's assume that this equation has the roots n1 and n2. The sum of n1 and n2 should be equal to the b value of the equation, which is 4 here. And the product of these two roots should be equal to a multiplied by c, which is equals to 3. Now we need to think of two numbers which have the sum of 4 and product of 3. What are those two numbers? Yes, correct. It is positive 3 and positive 1. And now we rewrite the equation as x squared plus 3x plus x plus 3 equal to 0. Next, we divide this equation into two groups, x squared plus 3x plus x plus 3. In the first group here, we can simplify this by taking out the x and becoming this line. Lastly, we just need to factorize this into x plus 3 multiplied by x plus 1 equal to 0. The product of two numbers, if it's equal to 0, one of them must be 0, right? Because anything multiplied by 0 will be equal to 0. So we can say that x plus 3 equal to 0 or x plus 1 equal to 0 for this equation to be true. So x is equal to negative 3 or x is equal to negative 1. These are the two solutions for the quadratic equation. There are some special cases in factorization. The first one is when the equation is a perfect square. So when the equation is a perfect square, it will always follow the general formula of these two equations. So for example, we have x squared minus 20x plus 100 equals to 0. Here we can see that 100 is actually equals to 10 squared and 20 is equal to 2 times 10. So putting this onto this equation, we can say that x squared minus 2 multiplied by 10x plus 10 squared is equal to x minus by 10 squared. So here we can easily get the solution, which is x equals to 10. The second special case is the difference of the two squares. For example, in the equation x squared minus 49, we can say that x squared minus 49 equals to 0. Now, 49 is 7 squared. So we can also rewrite the equation as x squared minus 7 squared equals to 0. Putting this into this formula right here, we can factorize the equation as x plus 7 multiplied by x minus 7 equals to 0. Now we just need to solve for this. X plus 7 equal to 0 or x minus 7 equals to 0. X equals to negative 7 or x equals to 7. Now last question for factorization. Let's try to solve this equation by using the factorization method that we learned just now. So first of all, what we do is identify the a, b, and c values of the equation. So n1 plus n2 is equal to 6. n1 multiplied by n2 is equal to negative 1. What two numbers, when added, will result into 6, but when multiplied will result into negative 1? There are no such numbers, so we need to take an alternative method other than factorizing to solve the equation. Completing the square. This is a method that involves adjusting the left-hand side of the equation to make it a perfect square. So let's say that we have this equation here. The first step that we need to do in completing the square is to move the constant into the right-hand side of the equation. So we move 1 to the right-hand side and we get x squared minus 6x is equal to 0 subtracted by 1. Next, we need to take the coefficient of x here, which is negative 6, divided by 2 and squared the result. Why do we need to do this? Because we want to have a perfect square on the left hand side of the equation. So add 9 to both sides of the equation, we get x squared minus 6x plus 9 equals to negative 1 plus 9. As we discussed before, this one can be simplified to x minus 3 squared equals to 8. Now it gets easy from here, you just need to square root both sides of the equation and move the negative 3 into the right hand side of the equation. And we get two solutions of x, which is square root of 8 plus 3 or negative square root of 8 plus 3. Another alternative to solve quadratic equation is by using quadratic formula. So the formula is shown as x is equal to negative b plus minus square root of b squared minus 4ac over 2a. Now, where do we get this equation from? What is the origin of the equation? So let us prove the equation. We know that the general formula of a quadratic equation is ax squared plus bx plus c equals to 0. Now, by using completing the square method, we move the constant to the right hand side of the equation. So ax squared plus bx equals negative c. What we do next is we divide this equation by the coefficient of x squared. So x squared plus b over ax equals negative c over a. So let's continue. X squared plus b over ax equals to negative c over a. By using completing the square method, we take the coefficient of x, which is b over a, divided by 2 equals to b over 2a, and square this. b squared over 4a squared. Now we add this value to both sides of the equation. X squared plus b over ax plus b squared over 4a squared equals to negative c over a plus b squared over 4a squared. After that, we can simplify this into x plus b over 2a squared. And we can also simplify this into negative 4ac plus b squared over 4a squared. Square root both sides of the equation. X plus b over 2a will be equal to the square root of b squared minus 4ac over 2a. Don't forget to add the plus minus sign. And moving the b over 2a to the right side of the equation, we will get x equals to negative b plus minus the square root of b squared minus 4ac over 2a. So the equation is proven. Now let's try to solve a question by using the quadratic formula. Do it by your own first. So here we just need to actually identify the a, b, c values and compute it into the equation. It's that simple. So a here is equal to 5, b is equal to negative 13, and c is equal to 7. Compute everything into the equation, and in the end you'll get x is equal to 13 plus minus the square root of 29 over 10. The last method is by drawing a graph. So this method involves drawing the quadratic equation in a Cartesian coordinate. So for example, we have the equation y equals to 4x squared minus 5x plus 1. So what we need to do here is to construct a table of x and y values. So here I'm going to take the x values from negative 2 up to x is equal to 2. After we take the x values, we substitute these x values here into this equation. So for example, if x is equal to negative 2, then y is equal to 4 multiplied by negative 2 squared minus 5 multiplied by negative 2 plus 1 equals to 21. So here y is equal to 21. And you just do the same steps for the rest of the x values and plot it in a Cartesian coordinate. If you plot everything correctly, you should be able to produce a graph like this. So in this graph, we can see that the solution of the equation is these 2 points here, the intersection of the graph with the x. So we can see that it is 0.25 and 1. That's the solution of the graph. Determining the number of real solutions. In quadratic equations, there are what we call real and unreal solutions. So how do we determine the number of real solutions? We use the determinant. The determinant is expressed as capital D. So the determinant is calculated by squaring b and subtracting it from 4 multiplied by a multiplied by c. When the discriminant is less than 0, or when the discriminant is negative, there are no real roots. When the discriminant is equal to 0, there's only one real root. And when the discriminant is more than 0 or positive, there are two distinct real roots. The real roots can be seen in graph by the intersection of x-axis. Next, let us have a comprehension check to check how much you understand on this topic. This is the first question of our comprehension check. Feel free to pause the video and resume when you're done. Now let us discuss the answer for the first question of our comprehension check. Now in this number, we have the equation x squared plus 6x plus 11, and we need to change this into this format, x plus b squared plus q. So we need to use the completing the square method here. So first of all, what we do is we group this equation into two groups. So x squared plus 6x plus 11. And we take the coefficient of x here, which is 6. We divide it by 2. 6 divided by 2 is equal to 3. And we square it. So add 3 squared into the first group and subtract 3 squared from the second group. Why do we need to subtract 3 squared from the second group? Because we need to balance the equation. If you plus 9, you need to minus 9 again, so that the equation does not change. So this can be simplified into x plus 3 squared plus 2. Therefore, we can conclude that P is equal to 3 and Q is equal to 2. Next question. So again, feel free to pause the video and resume when you're done. The next question is to sketch a curve of the equation x squared plus 6x plus 11. So what do we need to do to sketch this equation? First of all, we need to construct a table of x values and y values. I'm going to take value of x from -5 and next we just need to substitute this x value, every x value here, to this equation. So if we compute this into the equation, -5 squared plus 6 times -5 plus 11, it will give a result of 6. And we do everything else with the same way. So now once we get all the y values, we know this is the first point of the graph, -5.6, -4 and 3, -3 and 2, -2, 3, -1, 6, 0, 11, 1, 8. And we just need to plot it in a Cartesian coordinate. And if you actually plot everything correctly here, you will get this kind of graph. Last part for the first question. Find the value of discriminant of x squared plus 6x plus 11. Part C of the question. We need to find the discriminant. Now we know that the formula for the discriminant is equal to b squared minus 4ac. So in the equation of x squared plus 6x plus 11, the a value is 1, the b value is 6, and the c value is 11. So we just need to compute this into the equation, which is 6 squared minus 4 multiplied by 1 multiplied by 11 equal to 36 minus 44, which is equal to -8. Last question and we're done. Again, feel free to pause the video to solve the question on your own and resume to check your answers. Moving on to the next question. This question is a bit more complex than the previous one. So it's actually asking us to do the same thing. We need to change this equation into this form. So we're going to do exactly the same method as what we did before by completing the square. So this one we need to group into two groups, which is this and this here. And we take the coefficient of x divided by 2 and square it. So add 2k squared to the first group, but don't forget to minus 2k squared to the second group. So this will be equal to x plus 2k squared plus 3 plus 11k minus 4k squared. So therefore, P is equal to 2k and Q is equal to 3 plus 11k minus 4k squared. However, if you notice here, the Q can be further factorized. We can further factorize the Q value. So how do we factorize this? First of all, arrange it into the general form of a quadratic equation. Now we identify the a, b, and c values here. A is -4, b is 11, and c is 3. So n1 plus n2 will be equal to b, which is 11, and n1 multiplied by n2 will be equal to a multiplied by c, which is -12 here. The two numbers that will fulfill these two conditions are +12 and -1. So we can rewrite the equation as -4k squared plus 12k minus k plus 3. And we group this into two groups. Simplify the first group by taking out -4k, and this will equal to k minus 3 multiplied by -4k minus 1. Now here you can actually simplify this by taking out the negative sign. So k minus 3 multiplied by 4k plus 1. So the final answer will be p is equal to 2k and q is equal to -k minus 3 times 4k plus 1. That's the end of the video. Thank you for watching and see you next time. This has been the four Mathsketeers. A. Don't forget to like, share, subscribe, and turn on notifications for